Welcome back, friends. This is our next session on Terraform, and you can see that I'm logged on to my AWS account, and our objective today will be to work with EC2, that is instances using Terraform. Before EC2 instance, I need to ensure that I have required VPC, that is virtual private cloud resources are created. So if I go to VPC, you will see that I have one VPC created, that is the default VPC for me, and I'm working into US, United States, North Virginia, that is US East 1 region. I need to remember that what is my default region. I need that during Terraform. So this is my default region. This is my VPC. I'll show you. These are the resources created before the session, which means this is a prerequisite. Initially, we consider this as a prerequisite. Later on, we will create all these things also using Terraform. But initially, we are considering that this is a default resources are already created as far as the networking resources are concerned. Let me show you the networking resources we have. So this is a default VPC, VPC ID. I need to capture it because this will be needed. So let me take note of this VPC. This is my VPC ID. I need this during my Terraform. Then inside this VPC, if you look at, we have access control list also, ACL. That access control list actually allow the incoming and outgoing traffic. If I click on this access control list, I created this access control list also, which access control list ID, and which is associated with the subnet, TSP subnet, and it is default. And also this is association, you can see here, and if you edit this, you will be able to see these associations. Let me click on this access control list ID, and you can see that rule number, all traffic, all protocol, all port, source is from internet, and by default we are allowing it. This is inbound rules. Access control list actually allows you to control the traffic, flow of traffic to or from your instance. So inbound rules means incoming traffic to the instance, and we are allowing from anywhere. We are allowing all ports. In fact, if you see explicitly, we are allowing port number 80 also. From TCP port number 80, we are on port number 80. We are allowing connection from anywhere, from everywhere. Similar, this is incoming. Outgoing also, we have all outgoing traffic allowed. So this is the access control list, which is actually controlling the flow of traffic to or from the associated subnet, because this is associated with the subnet. I have to show you the subnet also, which is going to be our default subnet. If you can see that this is my subnet created, and you can create this subnet by clicking on create subnet, and then attachment, that to which VCN, to which VPC it is attached, and the CIDR block, IPv4 CIDR block, and the available IP addresses, availability zone, and availability. You can see all availability zone ID, network under group. You can see everything. And in fact, if you go to the root table, you will see the root table also, which is allowing the internet gateway, which is connected to the internet gateway, meaning that any incoming traffic or outgoing traffic, if required to send to the internet gateway. Internet gateway is a kind of bridge that allows connecting traffic from the instance to go to the internet, means to all over the world. So internet gateway is configured, and it is destination is anywhere. This is we can call it as anywhere, and the target is from, that means if traffic is forwarded to or directed to anywhere, should go to the internet gateway. And when we say internet gateway, this means that this will allow going traffic to the outside world or from the internet. So this is the subnet. Once again highlighting, we have one VPC to which we have created a subnet also. This is the subnet created, and you can see that subnet details all the associations like availability zone ID, access control list ID, route table. Proper configuration is mandatory, otherwise networking will not work. So you can see the subnet ID, VPC ID, the CIDR block, and the route tables. So these are all, this is public route table and the association of this public route table. This way we have networking resources available on AWS, and I have captured these details. Let me capture the details of the subnet also. This is my subnet, and the subnet ID also I will be needing. So the VPC ID and the subnet ID. I need at least these two details during my Terraform. Once I have captured these details, let's go to the Terraform. Point to be noted, whenever you work with Terraform, you have to be inside one directory, and all the .tf file from the directory will be processed by Terraform. This is how Terraform works. The file has to have extension .tf. That means file name should end with .tf. Once we are inside the directory, all the .tf file will be referred. Also, we must ensure that AWS CLI, that is AWS command line interface, has to be configured with AWS space configure command, as I demonstrated in the previous lecture. So introduction part, in this we will understand this introduction: Terraform command, Terraform initialization, validate, plan, apply, and destroy. And these are the preconditions. Ensure that you have a default VPC in the respective region. We have that. I have created that. I showed you that a default VPC is created. Ensure that AMI, that is the image which you will be using to provision the instance, available, and it's available. In my case, I verified that image ID. Verify that AWS credentials are there in your home directory inside .aws directory credentials file. And then, by the way, if you are working on Windows, when you configure AWS with AWS space configure, it will by default put that into the location, and you have to take note of that location where this AWS is credentials are stored. This is the setting block. Terraform. Required providers is AWS. Source is HashiCorp AWS. Version you can specify. This is optional. It is in production. It is recommended, but not required for a training purpose, because in production we always pin a specific version for our environment, because slight change in the environment could create problem for our entire infrastructure. So whenever we work with real-time scenarios and production scenarios, we have to specify which version you will be using. Right now I have commented this out. Then provider block, because we will be working with AWS, so provider has to be AWS, and the profile is a default. Now this is the name of the profile which you will find in credentials file. Now AWS credential profile configured in your local desktop and terminal, which is from this file. Then region is US East 1. This is my default region. This is my resource block, means I'm going to create one instance, that is EC2 demo, and the image OCID, or the image name, the image ID, this is AMI ID, and the type, instance type is a T2 micro, means very small type. These are the prerequisite. If you are creating instance on AWS, you need the instance type, that is shape, also known as template, also you call it, because the template decide how much RAM will be given, how much hard disk will be attached, boot volume. So it will decide the resources to be consumed by your instance. That is decided by the type. Then Terraform core commands, we will talk about Terraform init, Terraform validate, Terraform plan, Terraform apply, and verify the newly created instance, and then destroy. This is what you will see. So the demo part is, let's start the demo now. You can directly start the terminal from Visual Studio Code itself, because here you will find inside the on the main menu you will find the terminal option, new terminal. So whether you are working on Windows or Linux, you will find the terminal available directly from the Visual Studio Code, and that's the good option to start with. I'm working in this AWS directory. This is my terminal available here itself, and if I try ls command, that will show me where am I working. As you notice, we are supposed to work in this directory. So let me switch to this directory cd 02, and inside that I am working on part 2, so I have to switch to this directory cd 0202, and here we have Terraform manifest. Inside Terraform manifest cd Terraform manifest, you have to be working inside the directory where your all .tf files are. Interestingly, these were only done when I was verifying it, so I can remove them safely for the demo right now. rm-rf Terraform, and putting a star, deleting everything, ls-al, and you can see there's some .terraform directory also. I'm deleting all of them. rm-rf .terraform, because I want to start everything from scratch. I want to show you. So there's nothing inside this now. ls-al, there's no hidden file other than this EC2 instance file. Let's understand how the minimum requirement to launch an instance through Terraform on AWS. This is the minimum configuration. Prerequisite, once again highlighting VPC, subnet, route table, and other requirement. We are not going to perform any other operation other than launching the instance and verifying it is available or not available and reaching to that instance. All right, that's what we will do, nothing much. So let's open this file. The file is available here, EC2 instance, and I can explain that .terraform file here itself. So this is the Terraform file. You can see here, this is the actual file. That was a discussion part, the explanation part, but this is the actual .tf file or the Terraform file. So this is the Terraform block that I will be using HashiCorp AWS, the version which will be used. This is provider block. You see provider profile is default, and my region is US East 1 as I explained, and this is which I have taken from the notepad file. Take note of this notepad file. This is the same subnet. I wanted to show you that you have to ensure that you match with the requirement. I'm increasing the size also. Just confirm that it is the same subnet 08E43, because right now we are assuming that we have default VPC and default subnet available. Therefore, this default subnet ID or default subnet name is to be given here. So that is why I was talking about this. So this is already included. In your case, this entry, if this entry is missing, you have to add it. Instance type, the image, and that's it. So this is the instance part. Now we are good to go. I'm in the directory. I have to run the command terraform init. This is the first command. What this command will do is, command will download the plugin required to interact with AWS. Incidentally, what it will do, it will create a file, create a directory .terraform. Inside that, if I try, I'll show you the file name also, ls-lh.terraform. Inside that, there's another directory, and here you'll find the file name, and this is the file, the plugin actually, which has been downloaded. It is 612 MB file. This file is responsible for making all the calls to AWS, means this is the bridge between AWS and Terraform. If you are using AWS provider, this file is mandatory. If you are using other provider, this file will change, nothing else will change. So for example, when Azure, the rest of the process will be similar, and the required provider in that case will be Azure. In this directory will be Azure in that case. So this way you can have multiple providers in the same directory. Again, one important point here is, if you want to execute the Terraform from some other directory, that won't be possible. This is the kind of very interesting fact that wherever you are working, Terraform has to be there, and all the .tf file provided available in that directory will be processed by Terraform, and only in that directory. You cannot specify a .tf file from somewhere else. The file has to be here only. The file is here, instance is there, I mean the .terraform file is created, the plugin is downloaded, initialized, and now what we should do is we should plan Terraform plan. I explained the concept of Terraform plan, and this is reading the content of the file .tf file and is telling you everything what is going to happen. If you see the output of this command, you can see here the AMI, the image will be this. ARN, I don't know, I will tell you after I apply it. Similarly, get password data false. So which shape, which type will be used, T2 micro. So whatever information I provided, you can see that information, but whatever information is not available, that is something interesting about Terraform, that you don't have to worry about that. You tell what you need, not how it is to be done. Rest everything will be taken by Terraform. So let me validate also Terraform, validate, and this will confirm that yeah, it is configuration is valid. Now I can simply apply. This will display the plan one more time, but this time if you are sure that you want to apply it, only yes will be accepted, nothing else. So type yes and it will create the instance. And let me go back to the console and show you my instance as it is being created. EC2, you can see the instance is running right now. In fact, it might be in process initializing. Yeah, I know it is initializing because it just now launched by the Terraform. So, and this is the public IP address of the instance. Now this is our first example of launching an instance with Terraform on AWS with prerequisite that we have created VPC and we have created the subnet. Now this instance is created and you can verify, and it is giving us the details also. Is instance created, creation complete. Now let's destroy it now. If you are done, you can destroy it. And that is something very interesting about Terraform. Terraform can manage the life cycle. Means if you created something, you can destroy with the Terraform destroy command. Again, it will display everything that what it is going to destroy, and this is what you will see. This is what will be done by Terraform. So if you type yes here, it will destroy this Terraform. So this was the first simplest possible example with launching an instance. If you see, the instance will be terminated. If I go back to the EC2 dashboard, you will see the instance is being terminated, or it might be already terminated that way. So let's see, it is right now showing at running, and let's reconfirm. Yeah, it is still destroying. I know it is taking time. Let me refresh. Gone. All right, that's all for this part. Thank you very much for watching. Bye bye.